Hello everyone, thank you for tuning into this video where myself, Randeep, and Ovoa will be talking about the latest innovations coming to Catalyst switching with iOS XE 17.14.1 and 17.15.1. So let's dive into it. First of all, we'll do a brief general release overview of iOS XE and how that happens. Then we'll do a brief overview of the Catalyst 9000 switching portfolio, from where Ovoa will take over and she'll discuss the latest capabilities coming with iOS XE 17.14.1, and then she'll hand the ball back to me and I will talk about what is coming with iOS 17.15.1. So in general, the iOS XE release scheduling has two different types of releases, one being the standard maintenance release or SMR, which gets support for 12 months. And then we also have the extended maintenance EMR release, which gets support for 3 years or 36 months. And iOS XE 17.14.1 is a standard maintenance release, while iOS XE 17.15.1 is an extended maintenance release with support for patches and more. And in terms of the Cisco Catalyst 9000 switching portfolio, we have a wide range of devices ranging from the Catalyst 9200 series of switches all the way to the 9600 series of switches. So in terms of the 9200 series, we have the 9200 as well as the L alongside the 9200 CX, a series of compact switches. Furthermore, we have the 9300 line, which encompasses the 9300L as well as the shallow depth 9300LM, alongside the Dash M 9300 series, alongside the 9300X series of switches. In terms of our modular access distribution offerings, we have the 9400 series, which also has the latest generation 9400X supervisor alongside various line cards that particular series of switches offers. In terms of our core offering, we have the fixed 9500 series as well as the modular 9600 series of switches, which also offer the Silicon One based X series within themselves as well, alongside different line card options also. And from here, I will hand over the ball to Ovoa and she'll deep dive into the Catalyst switching innovations that are coming with iOS XE 17.14.1.
Our focus will be on two key areas: platform and infrastructure enablement and programmability and automation. We'll explore the new feature additions such as 1 gig support on the 9500X and 9600X platforms, PTP support for the 9200CX, and the ability to modify IP SLA probe configurations via config replace. Additionally, we'll take a closer look at the enhancements in programmability, particularly the introduction of GNMI stream subscriptions with the unchanged mode. These updates are all about giving you more flexibility, control, and performance, and also ensuring your network is not only robust but also future ready. So let's dive in. In 17.14 release, we're expanding the capabilities of our Silicon One based platforms, specifically the 9500X and the 9600 line cards, by adding support for 1 gig capability. Due to the ASIC limitations, native 1 gig support on these switches is not feasible, but we've identified a growing need for 1 gig in core platforms. To address this, we've introduced two new special optics that can retime the signal from 10 gig to 1 gig. These new optics, now generally available, are the SFP1GLH and SFP1GSX, which support both single mode and multi-mode fiber use cases. It's important to note that these optics are only compatible with fiber modules, and they're specifically supported on the 9500X60L4D, the 9600LC48YL, and the 9600LC40TL4CD line cards. Each system can support up to 8 of these 1 gig optics. For copper requirements, we're actively tracking this for our roadmap, and currently these optics are supported only on SFP ports, not QSFP ports. In response to the growing demand, we're excited to introduce precision time control, which is PTP, support on the Catalyst 9200CX, starting with 1714. This is a significant upgrade, bringing the power of PTP to compact switches and opens up a range of benefits. For instance, PTP now offers direct mapping to Ethernet or UDP IPv4, and with packet-based timing, you can achieve accurate distribution and synchronization with minimal administrative overhead. It's a low-cost solution that simplifies management while enhancing network efficiency. The applications for PTP on the 9200CX are vast. It's ideal for scenarios like high-frequency trading in financial markets, where every microsecond counts. It's also perfect for multimedia broadcasting, ensuring seamless audio and video distribution. And in smart grid systems, PTP is crucial for fault detection and synchronization. Even in unique environments like courtrooms, where precise audio transmission from a judge's microphone is essential, PTP plays a crucial role. We support two different profiles on the 9200CX with PTP, the default profile and AES67. The topology diagram on the left shows PTP configured across the 9200CX switches, with the profiles running seamlessly. The 9400 here and the 9500 series shown on this topology act as grandmasters, and depending on your network design, you can also have backup grandmasters to ensure reliability. In the 1714 release, we're enhancing our programmability features by introducing GNMI stream subscription with the on-change option. Previously, we've supported GNMI subscriptions, where GNMI serves as the method for retrieving data, and subscribe here indicates that data collection occurs at regular intervals. Now, with the on-change feature, data is collected specifically when there are changes or an update to the data. We currently support this functionality with netconf and gRPC, and now we're extending that support to GNMI, ensuring consistency across different operational methods. Looking at the example on the left slide, you see a GNMI sample configured for periodic data collection. Here you have the options to choose between on-change, sample, as well as target defined. In this case, we've chosen sample, meaning we want to collect all the streaming data at regular intervals. In blue, you can see the payload generated by Young Suite for this configuration. The sample and the interval box indicate that we've set this data to be collected every 30 seconds. So every 30 seconds, the data is recollected. On the right side, instead of using a set interval, we've selected the on-change option. This means that data is only collected when there is a change, like when an interface status changes. For example, if an interface goes down, we don't want to collect data every 30 seconds. Instead, we want to collect it only when the interface comes back up or if there is another significant change. Moving on to this slide, we'll go a little deeper. On the black box here, it shows what's happening on the switch itself. We're displaying the telemetry subscription we created, where you can see that the upgrade trigger is set to on-change. This demonstrates our commitment to maintaining feature parity across GNMI, netconf, and gRPC, allowing you to choose the method that best fits your needs while ensuring consistent functionality. In previous releases, such as 1713 and earlier, there was a limitation with IP SLA probes where you couldn't modify them while they were active. It would initiate an error, and then it would tell you that the session is already active. Once an IP SLA session was scheduled, key parameters like frequency and other settings were locked in place, and this restriction was necessary to maintain consistency and prevent disruptions during active monitoring. However, with the release of 1714, we've introduced a valuable enhancement. Now you can modify running IP SLA probes using the config replace command. This feature allows you to change parameters on the fly. When you apply these changes, the probe automatically stops, updates its configuration, and then restarts, making the process far more flexible and efficient without the need for manual intervention. This improvement provides greater control over your monitoring processes, ensuring you can adapt your configurations as needed without unnecessary downtime. And that wraps up the updates coming in 1714. We've covered everything from enhanced PTP support, programmability features, to improvements in 1 gig capability. These updates are designed to make your network more efficient, secure, and easier to manage. Now I'll hand it over to Randeep Singh, who will take you through the upcoming enhancements in the 1715 release. Thank you.
Thank you, au revoir. Now let's get into iOS XE 17.15.1 and the latest capabilities coming with this specific release. So in terms of platform enhancements, we are introducing 1 gig support with transceivers for the Catalyst 9400X series of switches, alongside various capabilities coming within the infrastructure features, including MACsec and WAN MACsec support on port channel subinterfaces for the Catalyst 9500X as well as 9600X. We're introducing a new link debounce timer capability on the 9500X as well as the 9600X series of switches. We're bringing in AAA packless authentication with this release, alongside RFC 6286 compliance for BGP router ID. Then we'll talk about programmability and automation capabilities, alongside the cloud integration of Catalyst 9000 switches with AWS S3, as well as CloudWatch. Then we'll talk about Yang model support for L2 NAT CLIs. And then to finish off the session, we will be talking about something that is very important for us, and that is sustainability, and a new sustainability capability that we have baked into the Catalyst 9000 series with the enhanced energy monitoring capability coming with iOS XE 17.15.1. So let's get straight into it. First and foremost, in this release, we're introducing 1 gig support for the 9400X SOUP2 and 2XL uplinks with the SFP-LG-LH and SFP-1G-SX optics. And by the way, these are orderable now. 1 gig speeds are possible on the 9400X SOUP2 and 2XL chassis with these two specific SFP modules. Note, this capability is supported on native SFP 10 and 25 gig ports, and not supported on QSFP ports using QSA or breakouts. Existing GLC SFPs 1 gigs will not work with SOUP2 and 2XL uplink ports, just as a note there. Furthermore, we're introducing MACsec on port channel subinterfaces for the Catalyst 9500X and 9600X platforms. This feature provides robust encryption over both local and wide area networks, ensuring data integrity and confidentiality across your network infrastructure. In environments where high availability and bandwidth are critical, port channels are often used to aggregate multiple physical links. By applying MACsec on these port channel subinterfaces, enterprises can ensure that the data traversing these aggregated links is encrypted and secure. This in turn will enhance the security of the network by ensuring that even if one of the physical links is compromised or goes down, the data remains protected. Another benefit would be multi-tenancy, wherein a secure communication channel can be created with port channel MACsec support. Note that a maximum of 32 MACsec enabled sub-interfaces are supported on port channel. In this release, we are also introducing global link demounts timer. So think of cases where a switch port has false positives or the links are flapping. The new global link debounce timer feature delays the notifications of link status changes, reducing traffic loss caused by network reconfiguration when Ethernet ports experience minor faults. This enhancement ensures greater stability and minimizes disruptions due to transient link issues. This capability is being introduced on the 9500X and 9600X within this specific iOS 17.15.1 release. Furthermore, we're introducing AAA packless authentication. So PACs, short for password access credentials, are used to establish an authentication tunnel between the switch, the client device, and the authentication server, for example, Cisco ICE. So PACs are often the root cause of communication issues with the authentication server, such as ICE. And that could be after a particular reboot or due to a PAC that has expired. And PACs are also causing many governments with compliance issues since the negotiation of the PAC with ICE forces the use of TLS 1.0, and many governments have forbidden its use. So with the new AAA packless authentication feature, your switches can seamlessly switch to a secondary ICE node when the primary node is unavailable due to a reboot or whatever the ICE instance, for example, goes down, right? This ensures minimal disruption and continues network access, significantly enhancing the resiliency of your entire network in turn. Lastly, in terms of infrastructure enhancements built into iOS XE 17.15.1, BGP router ID compliance is present with RFC 6286 industry standard. So this allows for the configuration of IPv4 multicast and local range addresses as BGP router IDs. In addition to allowing peers with the same BGP router ID and different autonomous systems to establish a BGP connection. By adhering to RFC 6286, this feature improves the flexibility and scalability of BGP deployments, making it easier to manage complex network topologies. Now, moving forward to the programmability, automation, and cloud capabilities, we are pleased to announce that within the software release, cloud integration comes to iOS XE with AWS S3 and CloudWatch. With iOS XE 17.15.1, we're introducing seamless distribution of software images, software maintenance updates, SMOOs for short, software patches, and config files to multiple Catalyst devices using AWS S3 bucket, giving network administrators a manner to manage multiple files of their network on a central cloud repository. And we're also introducing CloudWatch, with which network admins can have the ability to gather and analyze syslogs for the entire network centrally on AWS. These two enhancements provide simple connectivity and configuration via AWS, allowing for a unified management experience while decreasing operational costs using cloud storage and distribution capabilities. So how does that look like? On the left here, we have a visual of how files are synchronized from a Catalyst 9K switch to the AWS S3 bucket. And we're also able to access the files from the switch itself, as well as the AWS webpage. And then on the right side here, we have the various syslogs sent to AWS by our switches, giving network admins the ability to monitor and analyze the logs without having to access the switches themselves via CLI. So this in turn also has various security benefits, including mitigating unnecessary access for all network admins to critical network devices. So how does that look like in action, right? So here I am logged in to my Cisco 9000 switch and I do a show run. I can see that I have a S3 profile set up, and with this specific access key, I have it integrated with AWS, right? And I have given it the read-write permissions, and all that information is here, right? So if I go into my boot flash directory into that specific AWS S3 bucket, I can see all the files within that specific directory. And right now I don't have anything here, right? So now if I was to open up AWS here and I go to my S3 buckets, I can go to that specific instance, right? And then I upload a file here. So I'll just upload a random text file. So hello.txt, upload it. And then I can see that it is here on my S3 bucket. And if I go to my switch, I also can see that I have the file available for me on my switch as well. So, I have the integration of being able to see on my devices physically as well as on AWS. And then with CloudWatch, I can integrate it seamlessly from my switch here as well with a specific access key, all right? And now from here, I will be sending all my syslogs to that specific AWS CloudWatch instance. All right. So if I go back to my AWS, or first, if I show my directory boot flash of my CloudWatch instances, I can see the specific log there, right? So if I go to CloudWatch on AWS, I can view my logs and I can see all the different logs for the specific different network segments I might have, right? So here's my specific pod with the various logs that I have from that specific lab, and I can deep dive into it and get logs from specific days and time frames as well. So all those capabilities are baked into this AWS integration. Moving forward, we are continuing to enhance our programmability and automation capabilities, and those continue to be very important areas of development for Cisco IOS XE. With 17.15.1, we continue to enable various cloud and on-prem controller use cases by continuing to invest in and innovate on Yang models. So for example, 5 common network management tasks, including ping, traceroute, throughput, MTR, and wake on LAN are now available through the Yang API to make your everyday tasks easier to do programmatically. And lastly, in terms of sustainability, Cisco continues to make sustainability a priority, helping to reduce the impact we have on the environment. Many of the power supplies within Catalyst switches are highly power efficient, up to a platinum rated 90% plus efficiency. With iOS XE 17.15.1, Catalyst switches continue to strive to maximize utility while minimizing power consumption. Coming in this release, the Catalyst 9200, 9300, and 9400 series of switches introduce enhanced energy metering. So this capability enables energy metering for switch system power as well as PoE switch port power consumption. So with this capability, we're able to account for switch system power consumption as well as that of the PoE devices connected to the switches, and then in turn report that power consumption in units of watt seconds. So this provides the ability to break down and visualize consumption of power within specific time windows and analyze and consider that when determining the carbon intensity reporting. So this allows for the density to time-based usage analysis and so on, giving you the ability to optimize the energy efficiency of your network as a whole. Here we see the additional 2 data models for energy meter telemetry, system power on the left, and PoE port power on the right. And with this last but very important feature addition, we conclude the features coming in iOS XE 17.15.1. So overall, this release has various different feature additions, ranging from the platform enhancements with the addition of 1 gig support with transceivers on the Catalyst 9400X. We have brought infrastructure features with the MACsec WAN MACsec support on port channel sub-interfaces with the 9500X as well as 9600X. We introduced the link debounce timer capability on the 9500X as well as the 9600X. We are also bringing forth the AAA packless authentication alongside the BGP router ID compliance with RFC 6286 industry standard. In terms of programmability and automation and cloud, we're introducing the AWS S3 and CloudWatch integration alongside the Yang model support for L2 NAT CLIs. And lastly, in terms of sustainability, we're bringing forth the enhanced energy monitoring capability. And with that, I will be concluding this video. Thank you so much for watching and hope to see you again.